Okay, this video is going to be on parabolas. Now we've done parabolas before, and when we looked at parabolas, we took a look at ax squared plus bx plus c. And we graphed them, we solved them, we did lots of things with them. Now, one of the important things that we looked at was this number here. The a told us basically whether it opened up or down, and then if it was very narrow or whether it was flatter, depending on what a is. Well, we're going to take a look at a new form and a new way of looking at parabolas. Okay, here's our definition of parabola. A parabola is the set of all points x, y in a plane that are equidistant from a fixed line and a fixed point not on the line. The fixed line is called the directrix, the fixed point is called the focus, and the vertex is the midpoint between the focus and the directrix. It is going to be either the lowest point of our parabola or the highest point. Now every parabola is symmetric, so it will have an axis of symmetry, which is a line that goes straight through the focus and the vertex, and it's going to be perpendicular to the directrix. Okay, this is how it works. Here's my focus right here. I need to find all the points that are the same distance from the focus as they are from the line. So for example, this distance here, let's say that's 2. Looks like about 2 centimeters. That means this distance would also be 2. Let's take another point. Let's take a point right here. If I connect that to the focus, and then I also connect it with a perpendicular line down to the directrix, those two distances would have to be the same. It looks like it's about 6. If this is 6, this is 6. I can take another point here. Let's say I take this point. The distance here looks to be, let's say about 9. That means the distance straight down to my directrix is also 9. So if you take all the points that are the same distance from the focus as they are from the directrix, you're going to get all the points along this parabola. And it goes on forever at both ends. Now, one thing to notice here, the distance from the focus to the vertex is actually the exact same distance as from the vertex to the directrix. It's going to be the same. Okay, in order to look at the equations for a parabola, I'm going to have to do it in a couple different pieces. This is what we're used to seeing. We've had this before, where I know that the vertex is HK. That's what I have here. Now, what we've done before is we've looked at this to tell us whether it opens up or down and how flat it is. Well, now we're going to use this A and this equation that says the absolute value of A equals 1 over 4P, and that's going to give us a special value called P. P is going to be the distance from the focus to the vertex, and then from the vertex down to the directrix. Okay, I need to look this other equation over as well. This is going to be different than what we've done before. Notice I've got x and then I've got y with a quantity squared. Now if you look at the general equation of x equals y squared, that's a parabola, but it's a parabola that opens to the right. Now I know that's not a function, but in our study of conic sections we need to consider parabolas that open to the right and to the left. Now here's my h and here's my k. Now the h is the x-coordinate and the k is the y-coordinate of the vertex. I will also need to look at the a here, and the a will help me find p, and p is the distance from the focus to the vertex and the vertex to the directrix. For example, let's say I've got a parabola like this right here. If I find out that P is, for example, 2 units, then I would go 1, 2, and this would be my focus, and I would go 1, 2, the other direction, and this would be my directrix. It would be 2 units away here, and this would be 2 units away here. So we'll look at a couple examples as we get going here. Okay, if we're asked to graph this parabola, I know from past experience that I can pick out the vertex as being +3 and a -5. If you are picking an x or y coordinate that's in the parentheses with x or y, you're going to take the opposite sign. So that's why it's a +3. If it's outside, we take exactly what it is. Okay, so I know the vertex is at 3, -5. Now, if I want to find the focus and the directrix, I'm going to need that special p number. Well, this is that a. And remember from before that the absolute value of a equals 1 over 4p. So the absolute value of a is 1 over 16. And what that means is we're not concerned with the sign on 1 over 16. I just need to take 1 over 16, set it equal to 1 over 4p to figure out what p is. Okay, now you can tell the only way I'm going to get these to be equal is if p equals 4. Okay, so now I've got p equals 4 and I have my vertex, so let's graph it. Okay, here's my equation again. I know that the vertex is at 3, -5. That's this point right here. Now, because I figured out that p was 4, in order to get to the focus, I would go 4 units up, and this is the point 3, -1. That's my focus. And then I would go 4 units down to get a horizontal line. This is the line y equals, well, let's see where that is. This is -5, -6, 7, 8, 9, -9. The line y equals -9 is my directrix. Okay, so now to finish graphing it, what I would need to do is just, now I don't need an XY table, but I need to have one point so I get an idea of how flat this is. So put in a point, let's put in the point 5, and the reason I put in the point 5 was because I'm thinking 5 minus 3 gives me 2, 2 squared is 4, 4 over 16 is 1/4, and 1/4 minus 5 would be -4 and 3/4. That's relatively easy to calculate. So I have the point 5, comma, -4 and 3/4. I would also be able to mirror that across here, and that's really enough to give me an idea of how flat it is. Okay, let's look at this one. Now this one has x, and then it has the y stuff that's squared. I'm still going to look at the same way of finding the vertex, but be careful here because what's with the y parentheses is my y coordinate. So my y coordinate is 2, and my x coordinate is going to be +4. So the vertex is 4, 2. Now, as far as how it opens, because it's x equals the y stuff squared, I know it's going to be left or right. And because it has a minus, I know it's going to open to the left towards the negatives because it has a negative sign. Now, as far as graphing it and finding the focus and directrix, I'm going to have to use my equation that takes the 1/2, ignore the sign, so I just take the absolute value of 1/2 and set it equal to 1 over 4p. Now, when I do the algebra on this, and I clear the fractions by multiplying both sides by 4p. I'll cancel here. This will cancel this, and I get 2p equals 1, which means p is 1/2. Okay, I am ready to graph it. So let's go to the next slide. Okay, let's look at the graph. I know that the vertex is at 4, 2. So here's the point 4, 2 right there. Now, because p is 1/2, I need to go 1/2 unit to the right and 1/2 unit to the left. So if I actually want to write the equation, this is going to be the equation x equals 4.5. A vertical line is of the form x equals a number. And I know that this is going to be 3.5, comma 2. 3.5, comma 2. That's my focus. Now as far as graphing it, I'm going to need to stick a value in there. And notice what I did. Because my equation is written like this, it's easier to put a number in for y. I'm going to put 2 in there because that gives me 0. And then negative 1/2 times 0 is 0, plus 4 is 4. So I have the point 4, comma 2. So here's 4, comma 2. Okay, that didn't help me. How much did it? So let's take something else that's relatively easy. Let's notice I don't have any y values to the I don't have any points over here. So let's pick something like let's pick negative 2. If I put negative 2 in for y, negative 2 minus 2 is negative 4, squared is 16, times a negative 1/2 is negative 8, plus 4 is negative 4. So I have the point negative 4, comma, negative 2. That's right there. So then I can mirror that straight up, because remember, I have running right through here, this is my axis of symmetry. It's my mirror line. Every parabola has an axis of symmetry that acts as a mirror. So if I have a point down here, I've got its reflection up here, and I can sketch my parabola. Okay, let's do one more example. Find the standard form of the equation of the parabola with the vertex 2, comma, negative 3 and directrix x equals 5. Now the first thing I would suggest is you just do a quick sketch of this to see which equation you're going to use. Okay, if you look at what I have here, here's the point 2, negative 3, right there. Here's the vertical line x equals 5. My parabola is going to have to do something like this. I don't know how steep it is, but it's going to have to be looking like that, because here's the directrix, here's the vertex. It has to open that way. The parabola will never cross the directrix. So because of that, I know that the equation I want to use is going to be x equals a and then y minus k quantity squared plus h. These are the equations. This is the equation for a left-right. Now, mine opens to the left. I'll deal with that later. Now, I know that k is negative 3, and I know that h is 2. So far, my equation is going to be x equals a times the quantity y minus a negative 3, that's plus 3, quantity squared, and then plus 2. Now, as far as figuring out what the a is, remember that a equals 1 over 4p. Well, come back over here, and how far was it from 2, negative 3 all the way over? How far is it from here to here? That's 3 units. I went from 2, negative 3 over to 5. So that's p. So over here, I know that a equals 1 over 4 times 3, which means a is 1/12. So I can go up here and take out my a, and I can put in 1/12. The last thing that I have to do is come over here and take a look at this. If it's opening to the right, I leave this as a positive 1/12. But my parabola is opening to the left, so I make it a negative 1/12. So that means my entire equation for this parabola is x equals negative 1/12, quantity y plus 3 squared plus 2. Okay, so there you have parabolas. We've talked about they can open left, right, up, or down. If they're left and right, you're going to have x, and then the y stuff is going to be squared. If they're opening up or down, the x quantity will be squared.